Let's figure out the derivative of sine of x straight from the definition. Here we go. If I want to find f prime of x, then the definition tells me that's going to be limit as h goes to 0 of f of x plus h, that's sine of x plus h, minus f of x, that's sine of x, and then the entire quantity divided by h. So now it's our job to reduce this, to take the limit and see what we can see. And what we need to do is work on this term of sine of x plus h. How can we reduce that? Well, you may remember something called the angle sum formula from pre-calculus or your trigonometry class. That's what we're going to use to simplify this expression. And so if you remember that, that's going to be, let me rewrite the limit. So that's going to be sine of x times cosine of h plus, now it switches, cosine of x times sine of h, and we're of course still subtracting sine of x. Everything divided by h. So this looks like we may not have made too much progress, but really secretly we've been preparing for this moment for the whole course. We've already got the tools. We have the technology to figure this out. You'll see what I mean in just a moment. So what I want to do is first break up this sum into two pieces. And the first one is going to be cosine x times sine of x over h. So I'm going to say limit, so h goes to 0. I'm going to look at cosine x times sine of h all over h. And the sum rule for the limit laws tells me that I can rewrite this limit as the sum of this term plus the sum of these two. So I'm going to be looking at the limit as h goes to 0. Now of the remaining terms, that's going to give me sine of x times cosine h minus sine of x. So sine of x times cosine of h minus sine of x. See, and I also factored out the sine of x as I was writing that there for you. And the whole thing is divided by h. So what I've done to go from this step to that one is I used the limit law that says if I have a sum of two functions, the sum of these two functions is that expression, then the limit of that is the sum of the limits. And here I factored out the sine of x. And sure, you might be saying, like, why rewrite it that way? You could have rewritten it a different way. I completely agree with you, but rewriting it this way is getting it into a form where we understand what we're looking at and how we can make a nice conclusion. And so let's calculate both of these limits. So first, let's calculate this limit up here. So if you remember, we've got variable h going to 0. Cosine x is therefore a fixed constant. As h moves around, x stays constant. We're taking the derivative at the fixed number x. So we can pull that cosine of x to the outside. That's the constant multiple rule. Cosine of x times limit as h goes to 0. Sine of h over h. So this one you're familiar with. Say it with me. Limit sine of h over h goes to 1. So that we've worked on before. And what have we got here? Let's pull out that sine of x, because once again, h is the variable, cosine h minus 1 over h. That's the variable, the function we're taking the limit. So h goes to 0. We can pull out that constant sine of x. We're multiplying by the limit as h goes to 0, now of cosine of h minus 1 over h. And this limit goes to 0. And that we've seen before also, and the argument for that was you multiplied by cosine h plus 1 on the numerator and the denominator, so you didn't change the value of the limit when you did that. And then using a trig identity, you reduced it to sine h over h times a quantity that was going to 0, and then you saw that the entire limit was going to 0. So this limit is 0. That means this entire term, that's sine x times 0, that's going to be 0. And so what you're left with now is cosine of x times the number 1. If you put all that together, this tells you that the derivative of sine of x is equal to cosine of x. So great, this is a fundamental formula. You're going to remember it for the rest of your life now. With a similar argument, you can start straight from cosine of x and plug in and use the angle sum formula for cosine, and you'll be able to prove on your own, I bet, that the derivative of cosine of x equals negative sine of x. So now that you've seen this argument, I challenge you to go back using the definition of derivative and prove that the derivative of cosine is equal to sine of x. So from now on during the course, we'll just use these two equations whenever we need them.